All right, geometry. So here are the four notes on using corresponding parts of congruent triangles. So as we continue on in our proofs, this is like the next step up. So in your previous proofs, they all ended with congruent triangles. Well, now in section 4.4, we're now going to take it one step further. So once we prove these triangles congruent, can you tell me that, that another pair of corresponding parts are congruent? One of the three that you do not use when proving the triangle is congruent. You might even have to take a step further and talk about things being parallel or something bisecting something. So, it all depends on what the proof is all about. All right, so notice it says with SSS, SAS, ASA, AAS, and I'll also throw in HL, right? Because we've talked about HL. You know how to use three congruent parts of two triangles to show the triangles are congruent. Once you know that two triangles are congruent, you can make conclusions about the other corresponding parts because by definition, corresponding parts of congruent triangles are congruent. Now, this is going to be a reason in your Delta Math proofs. We like to abbreviate this CPCTC. Corresponding parts of congruent triangles are congruent. So, for instance here, right? Say you're going to use, let's do side, angle, side, and side, angle, side. So that would be segment FG congruent to JK. That'd be angle G congruent to angle K, and that would be side GH congruent to angle KL, or side KL. So these are the three things you would know to prove the triangle is congruent by side, angle, side. So side, angle, side. So then in your next step of the proof, you could then say that either angle F is congruent to angle J, angle L is congruent to angle H, or side FH is congruent to side JL, and that would all be by CPCTC. Corresponding parts of congruent triangles are congruent. Okay, so that is the process. Prove the triangle is congruent with three parts, and then say something about one of the remaining three parts using CPCTC. Okay, so that's it in a nutshell. Now, I'm going to go over a couple things with you. So you must remember all of your definitions, all your postulates, and your theorems. I want to remind you of this one real fast, the Isosceles triangle theorem. Delta Math seems to enjoy isosceles triangles. So again, remember an isosceles triangle, if two sides are congruent, then the angles opposite those sides are congruent. So this is your picture. If two sides are congruent, then these two angles are congruent. Remember, this is called the base, and those are called the base angles. Now, the converse also works as well. So remember, for a converse, it's just taking the statement and flipping it backwards. So now, if I have two angles congruent, then I know that the two sides are congruent. And again, these two angles would have to be the base angles, and then it would be those two sides. So you might be using that in these proofs. Okay, so I am going to make a couple different videos because there's a couple different types of proofs included in this problem set. All right, so continue watching those videos.